Hey everyone, I'm Sam Kalpine. I'm the co-founder and chief technology officer of Allium Engineering. We are an early stage materials technology startup out of MIT, and we are working on solving the rebar corrosion problem. I'm going to present on an NCHRP Type 1 IDEA Type 1 project that we completed last year. We've had a lot of participation and support from V-Trans in this project, including Emily, Jin, and Logan. And sort of that project helped us develop this new material and manufacturing process to make it. And really the whole purpose and motivation for the project was to solve this really major issue in the durability of infrastructure, which is rebar corrosion. So all bridges and other reinforced concrete has a skeleton of steel inside of it that gives the tensile strength that it needs. But the problem is that when it corrodes or rusts over time, it actually expands in volume and basically breaks apart the concrete from within. These are kind of some pictures of what it actually looks like when this failure mode happens. These are pictures from all across the country, but it's really a major issue in Vermont as well as other places all across the country. And basically the idea behind what we're developing, you can come by my poster to learn more, is to actually coat it with a stainless steel to basically stop corrosion in its tracks. And one of the benefits that we sort of have discovered or realized is really the value around this technology is reducing the life cycle repair and maintenance costs. So this is one of the things we did as part of the project was a life cycle cost assessment and sort of compared this material against other competing technologies, conventional black rebar as well as epoxy-coated rebar. And if we could extend that lifetime of a bridge from 30 years to 75 years, or a bridge deck, I should say, that would actually reduce the life cycle costs of that bridge deck by around 75%. So that's really the value of this technology. And we can talk about that more if you want to come up my poster. This is kind of what we can talk about. If you want to come check out my poster, this is EDX line scan that actually shows the elemental profile across the material, where you can actually see the Stainless-Clad region with the higher chromium content, and then the core of the material, which is basically pure iron. And one of the things that I want to point out is that there's actually a smooth interdiffusion region at the interface between these materials. So it's actually metallurgically bonded through the diffusion of those elements. It's not a coating that could just be peeled off. There's a picture of what the finished rebar looks like in the middle there, and near the poster I've also got some samples. So if you want to come check those out, you're definitely welcome. And this is a picture of actually us producing this material with our commercial steel mill partner a couple of weeks ago. We can talk about more about the manufacturing process that we've developed to make the material as well. So that's it. So thank you.
Any questions?
I have one quick question.
We can hear you from back there, I think. Yeah, go ahead.
Yeah, so it is about I saw that in 75 years, it's quite cheap. I would like to know what is the difference in the initial cost.
Yeah, so it's maybe marginally more expensive than epoxy-coated rebar and maybe roughly the same price with like galvanized rebar.
Okay, great. All right, thanks.